Emotions Matter, brought to you by emaw.com. That's EMAWW.com. Your solution for emotional intelligence. Welcome to the Emotions Matter podcast. I'm your host, Monique. It's an honor and pleasure for me to introduce my guest today, Ash Furrow. Ash Furrow is a Canadian iOS developer and author, currently working at Artsy. He has published a number of books, built many apps, and is a contributor to the open source community. On his blog, he writes about a range of topics, from interesting programming to explorations of analog, film, photography, and music. And now, I'd like to welcome my guest, Ash Furrow. Welcome, Ash.
Thank you for having me.
Oh, this is great. Now, on your website, you mention that you had wanted to be a teacher. Now, where did we go from teaching to becoming an iOS developer?
Yeah, well, in high school, I'm from a very rural part of Canada, so we didn't have any computer classes, but I took some online courses through the high school and just fell in love with programming and writing. Having an idea in my mind about how I want something to work, and then being able to express that through code and see it work on the computer. That process still feels like magic to me. So at that point, I went to my mentor, who was my music teacher actually, and they helped me figure out which school to go to for computer science, and then that kind of I went from there into a computer science degree. But it's interesting because I do mention this on my website too, that I feel like I have sort of become a teacher because I did a lot of teaching assistants in university, and now I run a meetup where I help people to learn from each other. I volunteer with Coalition for Queens, which is a nonprofit that teaches people from underrepresented groups in technology how to code. So I'm not a teacher, but I do teach, and I really enjoy it. So I'm glad that I got to do both.
Yeah, you certainly don't need, quote, a license to be considered a teacher or a great mentor. And even just from reading your website and your blogs, there's such a wealth of information that you really have this gift of just being able to communicate directly to people as opposed to over their heads.
Oh, thank you.
As I said earlier, I'm not a tech savvy person, and so I was able to understand a majority of what you were saying when I was reading on the blog. It's oh, okay, I understand this.
Awesome.
So tell us, what kinds of apps or software have you helped develop that you are particularly proud of?
So I'm most proud of the work that I'm doing right now, which I think is typical for a lot of coders. Whatever they've done recently is what they're most proud of. So I work at a company called Artsy, ARTSY. The goal of the company is to make art as popular as music is today. And I really everything I do there is sort of in service of that vision. And I love it because a lot of my code, most of my code actually is all open source, so other people can learn from it. They can ask me questions about it. I don't think there's perfect software out there. All software has problems with it or compromises that had to be made while it was being developed. But I really like the work that I do there because it can not just help the company, but it can also help the industry move forward. So, for example, one project we took on a few years ago, there was a brand new programming language called Swift that Apple had released. It was still in beta. It was very early on in the community. The community was just forming around the language, really. And we decided at Artsy that the next project we were going to build was going to be written in Swift. And we were one of the first Swift apps that got built. It was open source from day one, so it was really great to see the community, ask us questions about why we were doing certain things. The project identified certain, things that needed to be built in the community. So, for example, the application that we built had to do some API calls, which just means it needs to talk to another computer over the internet. And we came up with a really kind of clever way to use Swift to help us do that. And that was spun off into its own project that is called Moya, and it's been like an open source playground for me just to try new things and build a community around. So it's kind of taken on a life of its own. The project Moya has over 100 contributors and lots of people who just kind of drive by and help us with typos or adding documentation and then leave. But some people stick around and help to further perpetuate that community and that sense of belonging that I've really tried to imbue there.
Wow, that really sounds fascinating. And I love how you got drawn to it because of an art organization.
Yeah, definitely. I mean, Artsy has 180 employees now. I mean, when I started 4 years ago, it was about 40. So we've grown quite a bit. But the engineering team at Artsy it's fewer than 30 engineers, and I really enjoy being a smaller part of something that's much bigger. It kind of humbles me. I like that.
Oh, that's wonderful. You kept using this phrase, and I noticed it on your website as well. You said that you are working towards becoming an open source by default. What does that mean?
Yes. Open source by default, it's a really good question. This is a phrase that I borrow from Artsy's CTO, and he's been writing about this for a long time. But open source by default is an idea that says the way we look at building software today is fundamentally skewed. So before I get into that, just to differentiate between open source and closed source, open source is when software is written such that anyone can go and investigate how it was written. They can look and see how it works, and they can answer their own questions if they wonder about how something is built or why. Closed source software, which is most of the software that is written today, is closed. So you're not able to go and investigate it and sort of tease apart how it works. So at Artsy, we practice open source by default, and I've sort of taken that on in my own personal world as well with the software that I build outside of Artsy. Open source by default basically says instead of having all software be written closed source and opening it if there's a good reason to, instead let's do the opposite. Let's make all software open source by default, and if there's a good reason to keep it secret or a good reason to keep it closed source, then we'll do that instead. And I love this because it's not saying that all software should be open source or has to be open source, because not all software should be. I mean, there's a lot of code at Artsy that makes the company valuable and very unique, and we wouldn't want to just give that away to other people. But there's also a lot of software we write at Artsy that doesn't help the company be unique or very valuable, and other people can benefit from it. So why wouldn't we let them benefit from it? Why wouldn't we help the entire industry improve a little bit through the course of our day-to-day work? So when I say open source by default, that's what I mean. And me personally, I'm trying to make sure that all the software I write, if I write a tool for myself to do something, even if I don't think it's going to be useful to someone else, it might be. And having it out in the open is better than keeping it secret and keeping it to myself.
So closed really means protecting copyright issues or even security issues.
Yeah, exactly. There's a lot of reasons to keep something closed source, but there's also the way we write software now is sort of like closed source by default. And that's kind of a shame because there are so many learning opportunities, and there are a ton of reasons to have open source code from like a social perspective, from a business perspective, from a personal perspective. For example, I wrote Moya out of a project that started at Artsy. Eventually, one day, I won't work at Artsy anymore, but I'll still be able to use Moya because that code that I wrote is open. So personally, I benefit from Artsy's open source as well.
So tell me then, also on your website, you give several speaking engagements.
Mm-hmm.
And one, which is a curiosity for us in particular here at the Emotions Matter podcast, is building compassionate software.
Mm-hmm.
Can you explain a little bit about what you mean by that?
Sure. Building compassionate software was a blog post and a talk that I gave at a few different conferences. And I named it Building Compassionate Software because I needed to hook people in without giving too much away. And it was sort of the vaguest, least memorable title I could give it. But the idea is that we want to build software compassionately. And that means having compassion for our users and compassion for our teammates and compassion for ourselves. Building compassionate software sort of took the audience through a few different points. The first one was that emotions matter. I explore some of the different research that's been done into feelings and emotions and team dynamics. And later on, I talk about psychological safety and how to operationalize psychological safety on a team, why you would want to do that, and how you can actually achieve a psychologically safe work environment. So that's sort of the umbrella that building compassionate software created for those different ideas.
Can you explain a little bit about why you say feelings matter in developing software? Because it sounds like what you're referring to really is the team relationships and maybe not the software itself, or can that lend itself into the actual building of that software?
I think primarily I was talking about the interpersonal relationships between team members, but absolutely that can extend to the actual software that's being written as well. When I say that feelings matter and when I say that emotions matter, what I'm trying to do is combat the stereotype that society has about software developers, that we are reclusive, that we prefer to be left alone to work by ourselves, that we spend odd hours of the day working and no one ever sees us and we'll be in basements for weeks on end or something like that. The idea that like coding is purely a sort of mathematical. It's coding is a form of communication. I'm communicating with the computer. Yes, I'm telling it what to do, but I'm also writing code to be read later on by a colleague, for example. So I'm communicating with my colleague. And when you think about programming in terms of communication, I mean, communicating is fundamentally a social skill. So what I'm trying to say when I say feelings matter is that the stereotypes we have about programmers aren't correct. Programming is a fundamentally social activity. And if we ignore the feelings that we have about our work or the feelings we have about how we work or who we work with, then we're sort of doing a disservice to ourselves. From the Project Aristotle that Google ran a few years ago, they did a comprehensive study of team dynamics and team performance. And they found several predictors of high-performing teams, and one of them was something called psychological safety, which is a fancy term for how willing people on a team feel to take interpersonal risks. So psychological safety is the feeling that if you speak up with a silly question or you admit a mistake, that you're not going to be punished or humiliated in front of the group. And I love this idea. I like working in psychologically safe work environments because just as a person, I like to be able to ask questions. But more important than that, psychological safety is a way to help teams be their most productive and do their best work. Feelings matter is sort of like a rallying cry that psychological safety, just sort of introspection about our own feelings and how we relate to each other, sort of encompasses.
And that, of course, then carries over into the creative process, which then
Hmm.
influences the nature of the software that you might be creating. That that there's a thought and an audience behind that, not just some vague person, but that there's a certain sense of care.
Yeah,
I see.
yeah, exactly.
Now, my next question then is talking a little bit more about the user. As I said earlier, I'm not a tech savvy person. And so, how do designers like yourself design software so that users like myself won't get
Hmm.
frustrated and that we will be, more inclined to continue using that software? Is there some kind of technique, motivation, or process that you have to go through to kind of ensure that happens?
Sure. Yeah, there are a couple different key techniques I think can help with that. The first one is just to understand the platform that you're building the software on. So, for example, if you're writing a web application, you're going to design that application differently than if you're writing an iOS application. And if you're writing an Android application, it's going to be different again. So understanding the platform is really important. And why it's important is because users are going to develop an intuition of the platform. They're not going to read the documentation that says like how big buttons are supposed to be, or which way certain animations are supposed to happen on the screen. They're not going to like understand that and describe it, but they're going to understand it in a sort of subconscious way. So if you can adhere to the user's expectations, then that's going to help them feel more comfortable with your software, and it's going to help them keep using your software. So that's the biggest thing from the get-go. On iOS, we have something called the Human Interface Guidelines that Apple publishes, and it is a very comprehensive breakdown of how user interfaces in applications should be designed and how they should behave. So understanding the platform is really important, but also what's important is to do user testing. And I think this is something that the software industry probably could do a little bit more of. I mean, my team could certainly do a little bit more of it. I'm sure other teams could as well. And that's just sitting down with the user and putting some software in front of them and watching them use it, taking note of when they get frustrated and confused, and making sure not to intervene and help them because they should be able to use the software by themselves. And if they can't, then that's a really good opportunity for you to improve the software so that they can.
That's great. Of great value. I'm surprised that they don't use test subjects more,
Hmm.
but that must be
It's a
cumbersome
shame, yeah.
too. But maybe it's the time element. Maybe they want to get it out sooner and they don't want to take it through.
For
Um,
sure. And there's a component of that. If you test at the end, then making the changes that you need to make is a lot more expensive. If you put
mm.
a prototype in front of someone, you can identify those same problems a lot earlier. And my colleague Maxime, who's an amazing designer and developer, she told me that with only a few user investigations and watching these users use your software, you can get about 80% of the problems from just 4 or 5 people. So it doesn't take a ton of time or resources, but it has to be done early in order to be really effective.
The people you would use, do they have to know how to initially use this kind of software, or can you pick someone like me and say, "Oh, here, see what you can do with this," and
Well,
then go
that's
from
a good
there?
question. Yeah, I think that the users that you get to try out your software and take notes on that, they should be your target audience. So if I'm writing an application to help you manage your email better, you might be the perfect target audience for that. If I'm writing an application to help airline pilots do their job better, I wouldn't be the target audience for that. I don't know if you would, but I would want to seek out, airline pilots who are already familiar with a lot of the terms and conventions, so I would get the most valuable feedback from my target audience, ideally.
Now, when you build the software, how do you ensure that users' privacy and rights, are protected? Because there's this huge fear of of getting hacked all the
Hmm.
time. How do you help, reduce that sense of fear in working with the software?
That's a really good question because there's been a lot more public awareness of security issues with software. Over the past few years, we've seen an increasing number of hacks on large retailers or other companies that hold sensitive information like credit card numbers or social security numbers. So it's definitely something that the public is starting to become aware of, and I'm glad that they are, because it's something that the industry doesn't necessarily take as seriously as we should. So one thing that we can do to help is to provide what's called end-to-end encryption. This is so that, for example, if I'm writing a messaging client, and you're talking to your friend, you and your friend should be the only two people who can read the contents of your message, even though I'm transmitting that message to you and your friend. I'm not able to decrypt that and see what you're talking about. So end-to-end encryption is something that people are increasingly asking for out of the software products that they use, and we're seeing an increase in how that's used. And I think that in addition to end-to-end encryption, things like open source can be really valuable too, because if there are, it seems a little counterintuitive at first, but with more people looking at software, you can find security problems a lot more easily, and you can identify problems that you wouldn't be able to if the source code wasn't available. And this has a wide-reaching implications, of course. But for example, if the Volkswagen emission scandal, if you remember that from a few years ago, if the code that the engineers were writing had to be open source, I don't know if the engineers would have written it because their names would have been publicly attached to this circumventing mechanism. So if we're writing software that needs to be very secure, and coders know that their name is going to be attached to everything that they do, they're going to be a little bit more careful about how they handle the user's data because their personal reputation is on the line as well. So I think that there's a couple different solutions. Well, more than a couple. I mean, everyone has a different perspective on this, but I think that open source should be sort of a badge of pride that software developers hold, and should be something that users look for in addition to solutions like end-to-end encryption.
Very good solutions. Very good ideas. I like that. I don't know if you're aware of this, but EMAW is building an emotion detection API
Hmm.
and also an app for emotional awareness. Now, just in case our audience isn't familiar with these terms, can you explain what the difference is between an app and an API in simple words? You sort of touched upon it earlier, but I'm just going to kind of bring it back around in case
Sure.
others didn't catch that.
Totally. So most people are familiar with apps. Apps are synonymous with software. It's sort of like an app is how a human is going to communicate with software. An API is how software communicates with other software. So let's take an example of an email client, because most people are familiar with those. You have an email app that you use to compose emails and receive them and things like that. But that software is going to talk to an API in order to actually send the message or receive new messages from the email server. So you communicate with an app, and the app communicates through an API to other software.
Even I understood that. See, that's really simple then. Now, here's kind of an interesting question. AI,
Hmm.
artificial intelligence. Can you explain possibly what the difference is between what we would call AI software and non-AI software? How do they differ?
Sure. It's a big question, and the distinction between those two things is very ill-defined. So the distinction that I make is that in non-artificial intelligence software, humans are writing algorithms to do something, and in artificial intelligence software, humans write software that writes other software to do things. That's sort of the highest level approach I can give. So artificial intelligence is where we teach the computers how to learn, and they sort of take it from there. Where non-artificial intelligence software, humans actually tell the computers exactly what to do. And the reason why AI is so important is because when computers can learn, they can come up with solutions that humans might not have thought of. And that's kind of interesting. I mean, there are companies out there who, when they're solving very difficult problems, they want to get like an approximate answer, but not an exact answer. A really good example is Google Maps. When you try and get driving directions from two different places, Google Maps can't give you the best answer because computationally it'd be really expensive to get that answer, but they can give you a close answer, and they might do that with artificial intelligence. So what some companies are doing are generating AI solutions. They don't know how they work, and then they sort of backwards engineer from there to figure out why the computer did certain things or designed its solution in a certain way in order to understand and do research into more complicated algorithms that humans might not have otherwise approached. So it's quite a fascinating thing. I'm not an AI engineer, but I sort of I like to follow it at a distance, and it's very fascinating.
So, do they really
hmm
think for themselves, or has it been, encoded somewhere in their program and it just knows how to get to that?
Yeah, that's a really good question. We're quite a ways off from that sort of artificial intelligence. The AI that most computer scientists discuss, or what they're talking about when they say AI, is something called machine learning, where a computer is given a task. For example, you might have your phone, and it can identify a particular species of flower. So you're at a garden and you want to know what a flower is. It might use machine learning. And the way that you train the computer is that whoever writes the software, they would show the computer a picture of a flower, and tell it this is the species, and it gives these pairings over and over again. And over time, the computer learns that certain species of flowers have this color, they have this shape of petal, that sort of thing, and it looks for these patterns. And over time, over many samples, it gets better at identifying that particular type of flower. In the Google Maps example, there's usually a little report problem button on Google Maps. So if it gives you a incorrect address or directions, then you can let it know, and that sort of folds back into that learning process. So over time, the artificial intelligence gets better at giving solutions to the very specific problem that it's been trained to solve. So it's not a general purpose intelligence as much as it is a very specific way to solve problems in a way that it can learn about that problem over time.
Okay, so that makes sense. Again, it's just taking information that's already been put into it and then learning the patterns and the algorithms and all, and then it can make a better decision or
Yeah.
suggestion for you when you
Yeah.
ask the
And
question. Uh-huh.
exactly. We're on a really interesting sort of cusp right now. In the fall, Apple is going to be releasing a new version of their iOS operating system, and that's going to have a new way to use machine learning built into it. So soon we're probably going to see vendors selling these sort of solutions to developers, like the identifying the flower example. That could be like something that I, as a developer, buy to help my application do its job better. Or it could be speech recognition, or it could be things like recording the sound of someone's voice to look for aberrations that indicate they might have a onset of a neurological disorder. There's lots of different approaches to artificial intelligence, and Apple popularizing machine learning in this fall is going to be really fascinating. And I'm not sure exactly where it's going to go, but I'm keeping an eye on it for sure.
Just curious, and maybe Ash, you don't have an opinion on this one way or another. Is there a moral obligation behind software developing?
Yeah, that's a really good question, a very broad question too. So I mean, when I think of like the entire software industry, I think that as people, we have a moral obligation to make sure that the software we use is used for good and not evil, which is sort of a very, high level philosophical ideal. But I think that it's important. And if we look at other professions that have been around a lot longer, for example, law or civil engineering or medicine, I guess they're not careers, they're professions. They have professional societies and organizations, the American Medical Association or the American Psychiatric Association, for example, and they have rules, and they have rules that govern how you are to behave and conduct yourself as an engineer or as a practitioner of a specific profession. Now, software developers don't have that, and we don't have someone who is in charge of telling us what is the right choice and what is the wrong choice. And I think that is that's a shame, because a lot of engineers, I mean, we call ourselves engineers, but I don't know if we're doing engineering in the sort of way that a chemical engineer or a civil engineer does. We're building things, but we often don't have the time or the experience necessary to ask moral questions about, if we should do good or not. So it's definitely a problem. I think it's going to only get worse or sorry, the problem's not going to get worse. The problem is going to become more important to solve. That's a better reflection. So, as software continues to build new solutions, automate old tasks. Certainly with self-driving cars and things like that. We're at this point where we're automating people's jobs at a faster pace than people can keep up with retraining themselves, and how society deals with that problem of people who aren't unemployed, they're unemployable. I think that's going to be a real defining challenge for our species in the next century.
I have a listener who has sent in a question, and boy, you just pushed that right button. I I have a listener, and his name is Scott. And Scott's from Maryland, and it says that he works for an industrial plant, and that he is worried that artificial intelligence may actually, steal jobs from humans. And that's sort of the line you were going here. Do you think this is fantasy or reality? And how can we find that balance,
Definitely. I Well, it's clear. I think it's a reality. I mean, like, I come from a very rural part of Canada, and there are lots of long haul truck drivers in my family. And, computers are going to be replacing those jobs. They already are. We have self-driving trucks on the highways in North America already. So this isn't like a hypothetical far off reality. I think it's very pressing, and how we deal with that is going to be a big question. And I have my own personal opinions on what we're supposed to do. I don't want to get. I mean, you can't really answer that question without getting into a very political discussion. But it's something that we need to think about as software developers. I mean, if the code that I write is going to take a job away from someone and take their livelihood away from them, what am I doing to give back? What am I as a coder doing to make sure that their life gets better after the task the computer or the machine is doing after that task has been automated? And right now the answer is nothing. We're not doing anything, and that's not okay, and that's not enough. I think the software and IT industry needs to address this problem head on and work with policymakers in order to make sure that when we automate away a job, we give back in a way that just doesn't go to an increasing number of wealthy people. People need to be able to live, and I don't want to write software that takes away their livelihood.
Do you think there's any kind of line of business where this would never affect? You
That's a really good question.
know.
Yeah, is there anything out there that isn't automatable?
How about
I'm not.
morticians?
Well,
Well, I take that
yeah.
back. I guess they could be. But is there anything
It's
out there that a machine couldn't replace because it just can't?
it's it's an open-ended question. When I try and think of something, I can't really. I mean, even software development, I think, might be automated eventually. That you could, I mean, like on Star Trek, you just say, computer, do this thing, and the computer figures it out. We might be there someday. We might be there sooner than you think. So the people like me who are writing software and who are automating tasks, you know, we might get automated ourselves someday. Even pursuits that we think of purely in the humanities, computers are able to take source material and generate paintings. You can generate a Monet painting and see what the computer just like comes up with in the style of this artist. How long before computers have their own styles? Computers are composing music, things that are you know, we don't think of computers as being able to do, but they are. And every time I come up with an answer to your question, something that we wouldn't be able to automate, I'm not sure. I mean, like if we look back to early 20th century economics, there was this idea that, by the end of the century, we would have a 14-hour work week. And that never happened. But if it did, and if it could, again, and we extend that line towards an ideal, like how amazing would it be if we as a species just existed as a way of leisure or pursuit of higher learning and bettering ourselves. I mean, like that's very philosophical, but there's a world of difference between where we are now and that ideal of like a society that has been purely automated and allows us to pursue our higher ambitions. I'm not sure how we get there, but I want to get there somehow.
Wow. I mean, it sounds so sci-fi, but most sci-fi actually are predictions of the future.
Mhm.
I mean, we always talk about the beam me up, Scotty, as the first cell phone, as you were saying,
Yeah,
computer tell me this or something. Yeah.
totally.
Now we have, all those Siri and other Alexis, all these other devices where we say, a computer tell me,
Hmm.
Alexis tell me. So, I
Yeah,
mean, yeah, it is both, and I'll say scary,
mm,
fascinating, and just plain old mind blowing,
yeah, I agree with all of
where it
that.
can go. So with this, tell me you've kind of touched upon it in some of the answers that you've given to these questions, but how do you see or hope to see happen in the future of software development? Where would you like to see that go?
That's a good question. I would like to see a software industry that is more inclusive to everyone. So I would like to see a 50-50 gender split. There's nothing about software development that precludes anyone from any gender of being able to do it. So I'd like to see a better representation of our entire society in regards to sexual orientation and skin color and gender. I'd like to see that reflected in software because, from a business perspective, we're ignoring a lot of potential users and potential customers just because we don't have those users represented on the teams that build the software. And so that's a business opportunity. It's also a business risk. If we look back to the history of airbags, for example, airbags were designed first around the physical characteristics of the average engineer on the team, who were all white men, and they ended up killing and hurting a lot of women and children because they weren't a consideration in building that product. So there's not just a business opportunity, there's a business risk as well. I think that companies are starting to recognize that a lack of diversity and inclusion in the software industry is a real problem. I'm afraid that they're not taking adequate action on that. And I really hope that trend turns around, because it would be a real shame if the only people who got to benefit from technology were the people who look like me.
There you go. You just touched on a moral obligation.
Yeah, well, there you go. Exactly.
uh,
Yeah.
so tell us, what are some other things that are happening with you? Do you have any future products pending? Do you have, how can listeners learn more about you? Because I know from
Sure.
looking at your blog that you're a very diverse individual.
Thank
And
you.
so if you want to share some of those things, that would be great.
Sure. So I've been working in iOS development since 2009. It's been a long time. It's been a lot of fun. I'm sort of branching out into other spaces as well. At Artsy, I've been writing software in Scala and JavaScript and Ruby and a whole bunch of different platforms. So I'm kind of still deciding, which direction I want to go in. But on the side, I've been practicing photography for a number of years now. I picked up the guitar last year and have just been running with it. And it's been an amazing experience to learn music again. I studied it in school, but that was so long ago. So I don't have any like future projects I can point to. I can recommend the Moya project. We have a really amazing community, a set of community guidelines where if someone makes a contribution to the organization, no matter how small or slight, they're invited to join the organization and be a full member and participate in how we make decisions and things like that. So if that kind of thing appeals to you and you're an open source developer and want to avoid some problems that people can often face when they're developing code in the open, Google Moya, send me questions if you have any. You can contact me on Twitter at Ash Furrow, or you can go to my website, ashfurrow.com, and I've got more contact details there.
Can you spell the project name for us?
Sure, that's a great question. Moya, Moya. It's on GitHub, and if you have a question, you can open up an issue. It's named after a sci-fi character, so if you get conflicting results from this obscure Australian sci-fi, then that's why.
Well, thank you so much, Ash, for joining us today. I learned so much myself, with the terms, and boy, my imagination was going crazy just thinking about where software can go and how that affects all of us as humans, and that that maybe we should be more vocal about our needs as humans, and that might help influence a little bit of where the software developers, go down the line. I was just thinking here, you said photography and guitar, and all I kept seeing is a machine playing the guitar for you or taking your pictures, and you don't want to lose that. You don't want to lose that, as a human. You want to hear the. Can we say here that no matter what the machines and software may eventually do for us, quote, as humans, there is one thing that they can never do, and that is present the soul.
Yeah. I think technology is at its best when it helps us express ourselves and express who we are on the inside, and I think that's reflective of that.
Right. Thank you again for joining me today. And thank you for joining me, your host, Monique, on the Emotions Matter podcast.